Solving these simultaneous equations means finding values of x and y that fit both the equations. So the first step is to number the equations. Then we can find the value of one of our variables by eliminating the other one, which means getting rid of one of our variables, so we're left with just one variable. Now looking at the numbers in front of our variables, you can see that before the x we have different numbers, 3 and 2, and before the y we have the same number, which makes y easiest to eliminate in this case, and we can get rid of y by subtracting one of these equations from the other one. And it doesn't matter which way we do it, but since we have a larger number before our x in equation 1 than in equation 2, to end up with a positive value of x left, I'm going to subtract equation 2 from equation 1. So looking at it a term at a time, 3x minus 2x leaves just x, 5y minus 5y leaves 0, and 55 minus 50 is 5. So I'm left with x plus 0 equals 5, and this plus 0 doesn't affect my equation, so that just tells me that x is equal to 5. I can now use this value for x to find the value for y by substituting it into one of my original equations. And it doesn't matter which one I choose, but again one of them might be easier to calculate. So I'm going to choose equation 2, and then replacing x with 5, I get 2 times 5, which is just 10. And then I can solve this equation to find y, first by subtracting 10 from each side, and then by dividing each side by 5, which gives me a value for y of 8. And I can check these values for x and y by substituting them back into my other equation. In these simultaneous equations, x is 5 and y is 8.